Hmm. Hi. For this week, I decided to introduce our data collection procedures, and this was where we are going on with this stage. And we use some tools like MSLI to find the network device in my own apartment, and and we can see there are lots of different Wi-Fi name and also their interface, and also we can see the some grid about their signal, and then we use the IW list to select our own devices, and we can see this one. The first one is our Raspberry Pi MAC address, and we can see the quality, and we can also see the uh, RSSI grade about the signal is 40 dBm, and we can use ipconfig to find each MAC address of our Raspberry Pi, and the first three device is uh, our Raspberry Pi, and we also need to uh, use some equation equation to help us to transfer the RSSI grid into a distance. And so we have this function. Uh, it basically we use input the RSI grid and also the sensor signal strength and also some loss parameters and uh, and then just the whole equation and help us to find the distance between to transfer the Wi-Fi signal strength uh, to the physical distance, and we can see uh, oh, and we choose our RSSI grade is 53, and we can see we can get the estimated distance with this equation, and which is 5.84 meters. Yeah, and let me talk about uh, this function. For this file, we transfer the collected data to the AWS IoT and to do some further process and analysis. And the first part of this code is about the IoT configuration and connects to the AWS IoT course using the secure MQTT connection, and uh, and also we do some like Wi-Fi signal strength retrieval and use a system-specific command to get the Wi-Fi signal strength, just like what I've done before, and also do some setting about the MQTT client initialization and connect to the AWS core endpoint, and it's the main loop rapidly retrieval the Wi-Fi signal data and construct a JSON message and publish it to the topic on the AWS IoT core. And the messages include the device ID and the signal strength data and the timestamp. And then is a shutdown. For example, the script is designed for the monitoring the Wi-Fi signal strength from the Raspberry Pi device and also sending the data to the AWS IoT core for further analysis and integration with other IoT services. and also provide some real-time updates to the cloud-based dashboard or the application. Yeah.
Today I will introduce the project where we visualize a path movement within a room using Wi-Fi signal strength data, and the trace is calculated dynamically using the trilateration algorithm. And I will explain the first one, how the tray algorithm calculates the path position and how we use this position data to generate the trajectory on a floor plan and future steps to integrate real-time data and refine the systems. And first of all, the room, the footprint represents the physical layout of the room, and this is our sample room PNG. And three nodes A, B, C are positioned at fixed locations, which you can see we position the three nodes at these locations. The trilateration algorithm uses the signal strength from this Wi-Fi nodes to calculate the path position at each time step, and the calculated positions are connected to form a trajectory where we overlay on the floor plan. And for the first, let's code workout, and this is the first part where is our Wi-Fi nodes position, and this is the sample data of our RSSI, where we will replace this signal data from our AWS and dynamically transform the data from AWS to our backend code. What's more, and this is our generating trajectory. The resulting trajectory connects calculated positions on dynamic derives from RSSI values. And for the visual example, the plot displays Wi-Fi nodes positions as red dots. The path trajectory based on trilateral positions shown as a blue line, and the timestamp at each calculated positions. And let's see the example. As you can see, this is our figure, where this is our three nodes, which represents the Wi-Fi, and the blue line represents the path trajectory. And for the future integration, the first one is real-time data collection. We will integrate with IoT device to collect real-time Wi-Fi data and transmit it to AWS IoT Core. And then the second one is implement refining trilateration, implement a more precise signals to distance model to account for environmental factors like optical and interference, and add arrow heading for cases where trilateral fails. And scalable visualization extend the system for larger environments by adding more Wi-Fi nodes and use interactive visualized tools for real-time tracking. And the last one is cloud integration connected to AWS DynamoDB for storing history, RSSI, and trajectory data, and process data using AWS Lambda to dynamically update the trajectory. And this is the data visualization part. And as you can see, since our last demo video, we set up the AWS, and this part we have the visualization tool, and in a few days we will connect it to AWS and this visualization tool so that we can dynamically transform the data from AWS and we can see in our web or our app. Thanks.
Hi, so this is Xiaoling Huang, and I'm here just to basically tell the new progress we've made So this is my part of the web surface for the pad tracking, and here just to talk about like the progress I've made currently. So as you can see right now, the pad update is actually like working, but the problem is the locations are basically updated once per second. In order to basically smooth out the whole process, what I did was to basically uh, interpolate the points between the updated intervals, which resulted in, as you can see, basically they're moving in the correct way, but the problem is sometimes if the pads, let's say, go from the closet to the main room within the second, uh, like if I interpolate like on the website, basically what it shows is just that the cat um, teleport from this point to point B like within like the second, but actually what happens is it's gotta like move from point A to point B, and basically what I think the solution will be just to maybe make the update more frequent, which is what we're gonna do in the following week. Maybe try to iron this out.